Welcome to Rio Tinto. Today, I'm exploring one of the largest man-made excavations on Earth, the Bingham Canyon Mine, and checking out cool water treatment facilities and tailings. From hauling trucks taller than houses,
Look how big this tire is.
to water systems that keep the environment safe, I can't wait to show you what life is like inside Kennecott. Hey Kieran,
Hey, Liam.
thanks for meeting with STEMheads to talk about this cool pit you got here.
Yeah, thanks for coming up.
So what's your name and title here at Kennecott?
So my name's Kieran McRae. I have the pleasure of being the Surface Mine Operations Manager here at Kennecott. So I'm responsible for all of the mining operations and all of the production teams that move all of the ore and waste around the pit. This is the deepest excavation in the world. So the pit itself is about 2 miles wide and about 3/4 of a mile deep. For those in the Salt Lake Valley, we're actually mining below the Jordan River.
Nice. Do you know how much copper has been mined out of this pit?
Yeah, I believe we've mined about 20 million tonnes of copper out of this pit.
So what else is mined out of this pit besides copper?
We also get gold and silver, as well as molybdenum as well, which is used in steel manufacturing as well as paints.
Gosh, those trucks seem like a real beast.
They're expensive to run, right? That's some of the challenges about mining and why we need to continue to focus on efficiencies and why we need the technical expertise of people that can really make sure that we have good mine plans, efficiencies built in, and we continue to make sure that we do better and better each day.
That's interesting. Well, this has been an awesome interview, but do you mind if we go down and see those dump trucks?
Absolutely. Let's go down and we'll go see a haul truck and we'll show you what it's all about.
Awesome, let's go. Hey. What's your name and what do you do here?
My name's Allison Chatterton, and I drive this big haul truck.
Awesome.
So what kind of questions you got for it?
It's pretty big.
Yeah. This tire is about 12.5 feet tall. The truck itself is, I think it's 24 feet.
So what's your most favorite part about this job, would you say?
Driving this huge thing. I mean, who gets to drive a 2-story house for a living, you know?
Exactly.
And you actually don't need a CDL to work up here.
That's cool.
Since it's all on private property, they'll all teach you up here.
So would you mind if I go up and see what's inside?
Yeah, we can climb up the ladder.
Cool.
So we'll just climb up this.
So what's going on up here?
It looks a little interesting up here. There's definitely a lot of space. This behind you, we call this the grid box. So there's 2 types of braking systems on this truck. The first one's called the dynamic retardant. That slows the truck down and controls the speed as you're going downhill. And then we've got a service brake, which brings the truck to a stop or holds it in place. This is the cab. We've got our panel up here that'll tell us any of the different codes, like kind of like a engine light or anything that comes on a vehicle. The whole brake stuff that I was talking about earlier, you've got here.
That's cool.
Pretty interesting. You've got downhill cruise control right here that controls your speed downhill.
It's crazy. All this space and you get this.
Yep,
Just
right.
like a little square.
Yeah.
So how much weight do these trucks move usually?
So fully loaded, they can carry anywhere from 362 to 384 tons.
Tons?
Tons. So that's what? Upwards of 600,000 pounds. And then
That's crazy.
when the truck's fully loaded, it weighs over 1 million pounds.
For $1 million?
Over 1 million pounds. This beast
Wow.
right here.
That is a monster truck.
Yeah.
What does a typical day look like for you?
So we get here and we do our walk around inspection. That's just making sure the truck's going to be in operational order and so we can drive it safely. And then we hop in the cab, we head down to the shovel and get loaded and climb the hill at 7 to 8 miles an hour.
That was pretty slow.
Yeah, it's real slow. And then take it up and dump the load and just repeat that probably anywhere from 8 to 14 times a day.
I can't believe I just climbed into one of those giant haul trucks. When you stand at the top of the mine, they look like toys. But once you're standing next to one, you realize, nope, that's a 1 million pound machine that takes some serious skill to drive. Now that I've actually climbed up one of these giant haul trucks, it's time to drive one. In a simulator. Come on now, I wasn't actually gonna drive one. Hey George. Nice to meet you.
Nice to meet you.
So what's the thing I'm looking at here?
All right, so what we're looking at here is a simulator. And so we can run through several different scenarios, emergency situations, things like that, all in a safe environment before we actually put them out in the mine.
Nice. I mean, even though I'm not going to operate one of these, would you mind if I try it out a little bit?
Sure, no, that'd be great.
Cool.
I have no idea what I'm doing here, but I'll try my best.
All right, here we go. All right.
Tap the horn button, just get rid of that. Target up there. There we go. Now, sound you're hearing is accumulators are building pressure right now. All right. Gear selector here. You got reverse, neutral, and go left. Harder.
Hard left.
Circle around. You're gonna do a good turn like you're gonna exit. Now turning right. Don't want to enter that dent there. You're being loaded, so then we set what's called a wheel lock brake. That's what's gonna hold you in place while you're being loaded.
That's cool.
Now you're about 1,000,000 pounds loaded, man.
1,000,000 pounds, that's crazy.
Okay, driving a haul truck in a simulator was way harder than I expected, but so cool. It's a whole different level of focus and skill, but it makes sense. Safety comes first, and these simulators make sure everyone's ready before they hit the real mine.
Going right down into the pit now.
Oh, shoot.
Oh no, a golf ball.
Uh-oh. That's my bad.
So now that I've seen how the ore is mined and hauled out, I'm wondering, where do all the leftovers go next? That's why we're heading to tailings, where we'll learn about what happens to all the remains.
Hi, Paula. Hi, Liam. Thanks for getting to meet with STEMheads and talk about the cool stuff that Kennecott does.
Absolutely.
First off, what's your name and role here at Rio Tinto?
So my name is Paula Dowdy, and I'm the manager of tailings and water services. There are two products that come out of the pit. So there is a waste rock material that is just moved out of the way. The other material that comes out is ore, and what we have are tailings. And so once the ore goes through the concentrator and the metals are floated out, what's remaining is the rock that the metals were in. And so it's been ground up, and then it comes to the tailings impoundment. When it gets to us, we then send it to our cyclone stations. We have one on the west side and one on the east side of the impoundment. And it's in the cyclone stations that we separate what we call coarse tailings or underflow, which is this type of material, from a fine material, which is what we call the overflow or the slime. This is the whole tailings that comes to us. We have a large barge here in the center of the decant pond, which has about 20 pumps on it. And we pump that water to this clarification canal here, and we recycle about 45,000 gallons a minute back to the concentrator. So you'll see we have water trucks that are going on the roads, spraying. We have polymer. The term is called rhino snot. It's what they call it because it's nasty. I mean, it's like what you would think rhino snot is. It doesn't sound good. And then we also put magnesium chloride on the roads, and that kind of binds the sediment together to where it doesn't create dust.
Interesting.
Yeah.
So what happens if you don't control the dust?
It's a big deal. We do have an air quality permit. It could impact our neighbors around us and the communities. You know, there are days that we will see 50, 60 mile an hour gusts, and it's a challenge. We spend quite a bit of money and resources on controlling the dust.
So what kind of STEM jobs are needed here for a successful tailings operation?
So quite a few. What we have is geotechnical engineers that are monitoring, piezometers that are monitoring pore pressures throughout the impoundment as we're depositing and actually on the historic impoundment as well. You know, the pit and the concentrator are about 15 miles away from us, so hydraulic engineers, mechanical engineers. I happen to be a geologist is my background. We do have scuba divers that have to come out and do some work every so often. They will be out there diving to inspect the bottom of the barge.
As a scuba diver myself, that sounds like a really cool job.
We'll have to hire you when you get a little older.
We'll see. How does Kennecott benefit from keeping the Great Salt Lake healthy?
It helps us as the lake dries up. Quite frankly, we see a lot of dust ourselves, you know, coming from the lake when we have those high winds.
Standing here at the Bingham Canyon mine, I finally get it. It's not just big, it's huge. And it's not just about pulling copper out of the ground. There are so many STEM jobs here that all make it happen. This place is like its own city. Engineers, geologists, drivers, technicians. It takes a whole community to run a mine this size.
So how does this water compare to the water out in the Great Salt Lake?
We are highly regulated on what we can discharge to the lake. So this is clean water, higher quality than what you'd see out there.
Well, give me a straw and I'll start drinking.
Yeah.
From the biggest mine I've ever seen to the tailings pond that looks more like a lake, my tour of Kennecott was unforgettable. What started as just a visit to a giant hole in the ground turned into so much more. I discovered a mini community working together to power our world while protecting the environment. Thanks to Kieran, Allison, George, and Paula for showing me how STEM powers such a massive operation. Catch you on the flip side, STEMheads.